So what's going to happen? This is fast. This is slow. Okay. So what's going to happen is that the wavelength is going to get bigger. The reason it gets bigger is that, of course, what V is F lambda. So lambda is just V over F, right? Frequency stays the same when you go into another medium. But if the velocity increases, of course, the wavelength increases. And then what it looks like in this case is it's like, you want to draw these guys parallel. They don't ask you to draw them, but it helps me to draw them, right? So these wavelengths are bigger than those wavelengths because this is faster. Okay, and then if we draw the direction that they're going, right, we want to draw a line that's perpendicular. So this should be a perpendicular line, and that's the direction that these waves are traveling. This is the direction that these waves are traveling. Okay, and the angle that they're actually asking us to find is this angle right there. They say find the angle between the normal to the wave fronts and the shelf. So for the wave in the deeper water, this wave, right, find that angle right there. Okay, and I feel like I've actually drawn that angle badly, but that's okay. Okay, yeah. Okay, so what we want to do is if you look in section 4.4, the first equation is sine theta 2 over sine theta 1 is V2 divided by V1. Right? I'm ignoring the part where the ends are because we don't have the indices of refraction here. So I'm going to call this medium 1. I'll call this medium 2. And we can plug in some numbers here. Oh, wait, we need to do some, we need to do a little figure in here. Let's change colors. Let's try red. Okay, remember that for refraction problems, the angles that we find, this angle, this is right angles to that boundary, right? And then we want to draw that same thing here, right? The angles that we're going to find are this angle here and this angle there. Those are the ones that go into here, right? So this is actually theta 1. This is theta 2, okay? And then V2 is 20 centimeters per second, right? And V1 is 15 centimeters per second, right? Okay, so now we're set. Let's see. Sine theta 2 is what we're trying to find, right? Trying to find that angle over sine. And then what is this angle? Well, I'm going to argue that it's 30 degrees, right? Because these guys, this angle and this angle are actually complementary to the same angle. They're both complementary to this angle because this makes 90 degrees, right? And this makes 90 degrees, okay? So these two are congruent, so therefore theta 1 is 30 degrees, right? And then V2 is 20 and V1 is 15, right? And now we can solve for theta 2. Theta 2 ends up being between 41 and 42 degrees, okay? Now, you would think that would be the answer, but they're not asking for theta 2. They're asking for that one. Theta 2 is actually the complement of the angle that they want to find. So once you find theta 2, you're going to go 90 minus theta 2 is theta. That seems unfair, right? I mean, you ought to be able to figure that out, but this seems overly complicated, in my opinion.